All right, guys, I'm going to try and rock this out in about 15 minutes because that's all I have until the next class starts. All right, so this is your practice test for your test, which is going to be tomorrow. First problem, you're just going to be graphing points. All of you should be able to do this. You know you've been graphing points since middle school, so it's just a matter of remembering that the x value is the first thing given and the y value is the second thing given. Because look at the graph. It tells you x is this side. It tells you y is this side. So for the first one, negative 2.5 goes there. Negative 1, 1 is right there. 0, 2. This is 2, 0, not 0, 2. 1, 4 right here. And 2, 8 right here. All of these should be something that looks like something we have been doing. And this one would be exponential. It is not asking you to write that. It is not even worth points on there, but just to put the graph with the name, I want to make sure we get that in there. Now, the next one, again, negative 1, 6. I'm kind of going through these fast. 0, 0. You should be plotting these as well. 1, negative 2. 2, 0. And 3, 6. And you can see that that is a parabola, which means that it is quadratic. And then negative 1, 8. Oh, way up here. 0, 5. And what you'll see really here is this is a linear function with a slope of negative 3 because it is going down 3, right 1, consistently, all the way through it. Okay, so that is linear, which actually kind of helps us do these problems down here. This one you can see is a straight line, so it's linear. This one you can see is an upside down parabola, so it is a quadratic. This one actually is not something you should recognize because it's not any of them. Not one of them, that's good enough. And this one here, of course, is exponential. Okay, now, when you look at an equation, you're looking for specific things. You're looking for, if it is to the power of x, it is exponential. If it is to the power of x, is it exponential? I don't see any other ones like that. If it is to the power of 2, it is quadratic. If you see power of 2, it is quadratic. It doesn't matter. Okay? And that's it for those. Now, if you see y or x by itself, in other words, there's no exponent attached, okay? Well, then it is linear. This is y equals negative 5 is a line that looks like that. So this is linear. It has a singular y. There's no exponents. This is an exponent attached. That would be a neither because that's not squared and that's not an x. This has no exponents. It has x and y. That is linear. This is just weird. That's neither, okay? All right, so looking at the exponents or lack of exponents, that's really how you look at that. This is just what kind of thing is it doing? This, if I look from here to here, I'm adding 12, adding 4, then all of a sudden I'm subtracting 4 and subtracting 12. That should look like, well, one of these. So that would be quadratic, okay? This one is minus 4, minus 4, minus 4, minus 4. This is what it means by showing your work. You could be doing, like this side goes down like plus 1, plus 1, plus 1, plus 1, and then those change. This is all plus 1, plus 1, plus 1. Really what I want to know is what is it going up or down by that will make you know that because this is a consistent number that it's linear. And it's add or subtract, whereas multiply or divide, and it might be hard to see it with fractions, but 4 times 3 is 12, and 12 times 3 is 36. And guess what? I'm going to make that consistent, guys. I'm not going to try and fool you. So that would be E for exponential, and we've already got through the first page. Okay. All right, so make sure that you got all this stuff down. I'm definitely going to check this tomorrow while you're taking the test, because really having this video, you should have no excuse. We got 10 minutes. Let's get to the next page, which is a long page because there's a lot to do here, okay? At the top, it's not so bad. If you remember, it is opposite same of what's given in opposite same of what's given in parentheses, then what's given outside of it. So the vertex here is the opposite of negative 4 and the same of 3, like so. And then your vertex here would be negative 1 and negative 4, like so. Axis of symmetry is x equals whatever the x value is. It is worth a half a point to put x equals. If you just put 4 here, it's going to be wrong. X equals, well, of course, the x value here is negative 1. Now, to determine whether it's a max or a min, remember what this number in front does. If it's negative, it looks like this, and that point is a maximum. Versus in front here, if it's positive, well, then it opens up, and that point right there is a minimum. And that kind of helps us do the next couple of problems. I need something that opens down, has this vertex, and is wider than the parent function. So we start with y equals, and it's going to be for both of these problems. We've got to have something in parentheses squared, something in parentheses squared. We've got to have x in both of them. And we know we've got to have these points. So I'm going to fill that in, and all of this is the easy way to at least get one out of the 2 points. Same thing here, opposite, same. Okay? Now, for what's in front, if it opens down, it must be negative, versus opening up is going to be positive for this one. And if it's wider, that means it got like this, it got wider. That means that A was a fraction. We have talked about that, we've seen it. If you were to do these problems down here, you would see it even more, but A is a fraction, so I'm just gonna make it negative 1/2, whatever, okay? Negative 2/3, whatever you choose. This has to be this way, this could be any fraction. And this, to make it narrower, would be any number greater than 1, any big number. So I'm going to put, I don't know, 4, 3, 2, any of those numbers. Even 2.5, it just couldn't be less than 1, okay? All right, then down here, anything with a vertex of this and the vertex is a maximum. Again, if it's a maximum, it has to open like this. So A has to be negative. So negative x plus 2 squared and then plus 0 if you want, right? Opposite, same. This would be, again, I'd have x minus 4 squared plus 7. What am I going to put here to have a minimum? It would have to go like this, so it'd have to be a positive, doesn't matter. I can write any positive number in there. That's how those work, okay? Look at what it is saying. Maybe draw yourself a picture of what does it mean. Oh, that means that has to be negative. Oh, that means it has to be positive, and so on. And the numbers in parentheses and outside are always opposite, same. You should be able to check yourself. Opposite of this, same as that, yep. Opposite of this, same as that, yep, and so on, all the way through them, okay? So that kind of helps us into the next couple. We're going to kind of fill them out pretty fast together here, okay? Because the vertex is opposite, same. The vertex is opposite, same. The axis symmetry is the x value, x equals the x value. The y-intercept is always plug in 0. Okay, let's go fill in some more stuff. This is going to be a point. This is going to be a point. That's going to be a point. Domain, you should remember, is always all real numbers, so we can go fill that in for both of these right away. The range is going to involve the y value of the vertex. The range is going to involve the y value of the vertex. And x increases and decreases according to the x value of the vertex. Same thing here. Right, so we got a lot we got filled in already. Let's go find the rest of it. To find the 0 here, you plug 0 in right here, and it would be 1/2. You should be writing down all of this work, by the way. Excuse me. If you plug that into your calculator, 4 squared is 16. Half of that is 8 minus 2 is 6. Okay, so it gives me a point 0.06, which automatically means that's going to be a 6, but we'll see that as soon as we start drawing. Oh, of course the phone would ring. Just a second. Seriously. Quick, I'm taping myself right now. Okay. Sorry about that. That's kind of funny. So I graphed my point here. I got -4, -2 right here. Okay. I've got 0.6 way up here. I got this thing to use as like a line of reflection. That's what this means here, by the way. So I've got 4 away. I go another 4 away, and I'm right here. So -8, 6 right there. And I plot my points, or connect them, excuse me. Because it's going up, it is greater than or equal to right there. Remember, we do this little like number line thing, and if I cover it up with the left side, that side is going up, so it's increasing, which means that's decreasing. So decreasing gets this arrow, increasing gets that arrow. Right there, there's the problem. Come back over here, plugging in 0. I'm going to have -0 minus 1 squared plus 5, which is 1 -1, that gives me 4. You can again plug it just like this into your calculator, negative parentheses 0 minus 1 parentheses squared plus 5. So I've got 1, 5 right here. I've got 0, 4. This would be my reflection line. So I've got this point right here, which is 2, 4, which makes sense. Those should be the same. This is going to open now down, like so. So it is less than or equal to there for my range. And increasing and decreasing again, I'm going to increase on this side and decrease on this side, because when I cover that up, that is going downhill. So decreasing gets, again, that arrow, increasing that arrow. Okay? And that's it for that problem. For this problem, the biggest thing you need to know is the opposite of b over 2a. Okay, a is 3, b is 12, and c is 7. If there was minus signs, they'd be negative, but there's not. The opposite of b, so let me b, a, and c, is negative 12 divided by 2 times a, 2 times 6, or 3, excuse me, is 6, because this we have to do in parentheses. And I get negative 2. That gives me that value right there. And then I plug it back in to there, 3 times negative 2 squared, plus 12 times negative 2, plus 7. When you plug that in, you get negative 5. That gives me that value. Axis symmetry, again, comes from the x value. The y-intercept is 0, 7, because when I plug 0 in, that would cancel those two terms. Okay, it's point reflective. I don't know, we got to go. The domain is all real numbers. The range, the x goes to the x, and the x goes to the x. And so let's go graph this. Negative 2, negative 5 down here. 0, 7 is here. It reflects 2 away and 2 away to go here, because that right there is my reflection line. There's my graph. It's going up, so greater than or equal to, again, the y value, negative 5. I'm going to do the left-hand trick. That's going increasing, that's going decreasing. So decreasing again gets this arrow, increasing gets that arrow, and I'm done again. Okay, kind of sped through that, but it's on tape. You can rewind it as you need. Okay, let's go to the back side here. This side will go much faster. These first two problems, matter of fact, yeah, let's just do it. These first two problems, if I write that in order, negative 16 t squared plus 400 equals 0, because it's giving me the equation right here, nothing crazy. It's telling me what to plug in right there, and then the ground gives me height 0. Now that's worth a point right there, okay? And now what do? You do the same steps over and over. You get rid of the number. Those will cancel. Negative 16t squared equals negative 400. Then you would divide, of course using your calculator, by the number next to t. T squared equals 25, and then square root it to get 5 seconds. Okay? Same thing here. Again, it's the same formula. Negative 16t squared plus 150 equals, it tells me 6. That's worth a point. Then it's the same steps. Minus it first, just like we did on the other one. Divide it, just like we did on the other one. T squared equals 9, and then square root it to get 3 seconds. Okay? Those are the same steps over and over and over. These problems are really simple if you just identify what the vertex is. The vertex here is negative 3, negative 2. It's just saying what is h. H is negative 3, because that's what we found here. This is h and k. Same thing here. This is negative 1, comma 3. Negative 1, 3. K is 3. That's it. That's how you answer those, because it's just the y value. Down here, if you remember, we're going to do the x box. Okay, the first term goes here, the last term goes here. I know you heard the bell. I'm going to try and speed this up. This is 1 times that. The middle term always goes here. We figure out the terms that multiply to give me this, but subtract to give me that. 6 minus 2 will give me a 6x there and negative 2x there. And you do GCF, 6x, x, negative 2. There it is. Okay, it works again like that over here. X box. Put the first term there, the last term there, the middle term there. This times this is 12 right there. That's negative 12 times negative 1. Put that in the box. GCF this way, I get negative 4. 3x, or excuse me, just 1x, sorry. This way is 3x, and minus 1. There it is, x minus 4, 3x minus 1. Okay, and then the last problem, this factors to give me, you can do x box with this one too. So I get x squared, negative 3, 2 goes here. I got, this times this is negative 3, so that is, let's see, 3 minus 1, 3x and minus 1x. 3x, x, negative 1. Look, x minus 1 is this, x plus 3 is the other one, so that means that that's 3. And that's it. With 30 seconds to spare, we got through the whole thing. So make sure you're getting this all in. Even if it means this is the only thing you do today is watch this video and copy it in, at least you did something. Maybe watch it twice. You have plenty of time in class to do that. Thanks for your time, and be ready for this test tomorrow.